All right, here is part one from section 4 from the first practice test from the redesigned SAT. So this is the calculator section of the math calculator section. And so what I'm going to do in this video is go through roughly the first 10 problems here. So let's get started. On this first one, you're told that John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during his workout. So here's the time, here's the heart rate. The question is, on what interval is the target heart rate strictly increasing and then strictly decreasing? Really, all you need to know for this problem is what the hell that means, strictly increasing and strictly decreasing. Increasing is probably not surprising to you. That means kind of going up as you read the graph, whereas decreasing is going down. Strictly means increasing and going up the whole time, so not going up and coming flat or something like that. So what you're looking for is a region where the graph is strictly increasing, aka going up, and then strictly decreasing with no flat parts in there. And so you're like, oh, here it's increasing and decreasing, but unfortunately it's flat there. But right here, from 40 to 60, it looks like we're strictly increasing and then strictly decreasing. So it looks like from 40 to 60 minutes, we're satisfying this criteria. Note that doesn't happen anywhere else on the graph. Therefore, our answer would be B here, between 40 and 60 minutes. Number two. Number two, it says if y equals k times x, where k is some constant, and y equals 24 when x equals 6, what is the value of y when x equals 5? Okay, so lots of information in here. What I think is easiest is to realize that they told you that y equals k times x. And then they also told you that when y equals 24, x equals 6. So what we can do is figure out what k is. K isn't given in the problem, but since it's a constant, we can solve for that value. We can divide both sides by 6 here. 24 divided by 6 is 4. So I get that k equals 4. And if I know that k equals 4, then really what I know is that y is equal to 4 times x. So I can kind of take that and plug it in up here. And so what I'm trying to figure out is what is y when x equals 5? Well, that's not too bad. All I got to do is say it's 4 times 5, and 4 times 5 is 20. Therefore, y equals 20 is my answer, and C is what I marked down here. All right, number 3, in the lines above, or in the figure above, L and M are parallel as they appear to be, and T and S are parallel as they appear to be. And you're told that the measure of angle 1 is 35 degrees. So this measure here is 35 degrees. And you're asked what this angle measure is. It turns out it'll be the supplement of 35 degrees. And the way you get there, not that you need to show your work on the SAT, but just for your benefit, because lines L and M are parallel, so completely ignoring the fact that S and T are parallel, but just because L and M are parallel, that tells us that this angle here, 1, has got to be the exact same measure as this angle here. They both have to be 35 degrees because these lines are parallel. And then forget for a minute that L and M are parallel, taking advantage of the fact that S and T are parallel. This angle here has to have the same measure as this angle here. So this angle has to be 35 degrees. Unfortunately, that's not what we want. We want this guy right next to it. However, this entire thing, this arc here, has to be 180 degrees, right? It's halfway around a circle. A circle is 360 degrees if you want to think about it that way. So if the entire thing in red is 180, and I've used up 35 over here, then the measure of angle 2 is just what's left over, the 180 minus the 35, which is 145 degrees. And that's answer D here. If you were doing this on a test, you could do this a lot quicker. If you kind of look at this picture, this is clearly less than 90 degrees, right, as is this one. Or actually, I guess you could jump all the way over to 2 here. This is clearly more than 90 degrees, right? Yeah? Well, only one of these answers is more than 90 degrees, so the answer has to be D immediately. It's the only one that's more than 90 degrees. 90 degrees is something that looks like that. So either way, use the 90-degree trick, or this method will work more generally on problems like this. Number 4. If 16 plus 4x is 10 more than 14. Okay, some key words here. When you have these kind of word problems that have to do with math, is typically going to mean equals. More than is going to mean plus. So when you read this, you got 16 plus 4x is 10 more than 14. So I want to take the 14 and then I want to add 10. I know that order is a little bit weird. You might have wrote 10 plus 14. It would have worked out the same because addition is commutative and 14 plus 10 is the same as 10 plus 14. But really, 10 more than 14 I think should be written this way. And that can be a little bit picky. If it were 10 less than 14, we'd have to write 14 minus 10. So for this problem, it doesn't matter a whole lot, but for generally speaking, you might want to write it in this order. I got 16 plus 4x is equal to 24. You could guess and check if you felt like it, but it's probably easiest just to solve this algebraically. Subtract 16 from both sides of the equation. 24 minus 16 is 8. So I got 4x equals 8. Divide both sides by 4, and I get x equals 2. Looks like that's this answer here. Nice thing about these problems is they're fairly easy to check. If 16 plus 4x, well, if x is equal to 2, this is 8 plus 16 more is 24. If 24 is 10 more than 14, yep, that sounds right. Looks like I got the right answer there. Number 5. Which of the following graphs shows a strong negative association between D and T? Well, I guess you need to know what a strong negative association is. If you know what that is, this problem's super easy. If you don't, it's kind of impossible. The answer is D. Negative association means that when one of your variables goes up, in other words, when you read this thing from left to right, the other variable goes down. So when I read this thing from left to right, I want the heights to be going down. And you're like, yeah, that kind of happens up here in A. It doesn't happen here in C at all, right? If I go from left to right, these are clearly going up. In B, as I go from left to right, it appears they're staying more or less flat. But in both A and D, they appear to be going down, these data points, as I read this from left to right. However, this is a stronger association because it's more clear here that these points are going down than it is here. Here, it kind of looks like it's going down, but they're sort of all over the place. Therefore, the answer is D. Kind of a vocabulary question, which I don't know how useful that is. If you know what these words mean, it's pretty easy. Otherwise, it's useless. Not a lot of thinking going on. Number 6. Number 6 says, a hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? So the way I like to write these, and this might be a bit overkill, but you have 2 decagrams. Maybe I'll write it as 2 dg. And what I want to do is express this answer in milligrams. So I want question mark milligrams. I'm going to fill this in right here. And what I'm going to do is I am going to only multiply this by the number 1. And it's important that you only multiply by 1. If you multiply by any other number other than 1, you're changing the value of this thing, and therefore these sides of the equation wouldn't be equal. So I'm going to multiply by 1, but I'm going to multiply by a special form of 1. I know that 1 decagram is the same as 10 grams, so I could put 10 grams here and 1 decagram down here, and because these two things are the same, when you have a fraction where the top is the same as the bottom, the fraction is equal to 1. So all I'm doing is multiplying by 1. I'm not changing the value of anything. However, what I managed to do is I have, if you think about this 2 decagrams, really it's 2 over 1. I can cancel these units. These decagrams are on the top and these decagrams are on the bottom. So those cancel out. My new units are in grams. But I don't want the units to be in grams. I want them to be in milligrams. So I'm going to multiply by 1 again. I'm going to say I know 1,000 milligrams is the same as 1 gram. I want to get rid of grams because grams are what I have on the top here, and I want my answer to be in milligrams. So I'll put the grams down here and the milligrams up here. And in order to make this equal to 1, the top better be the same as the bottom. In other words, I better put 1,000 milligrams if I'm going to put 1 gram. And now what you see happen is this gram and this gram cancels out, and the units that I'm left with are these milligrams, which is fantastic because that's what I wanted. And so now I got to do is multiply. 2 over 1 times 10 over 1 times 1,000 over 1 is 20,000 over 1, aka 20,000, which is the answer here, D. Wait, couldn't I have just taken 2 and multiplied by 10 and then multiplied by 1,000? Yeah, that's exactly what you do. But the challenge is there could be different units given to you where maybe you take the 2 and divide by 10 and then multiply by 1,000 or something different like that. So setting it up in this way will work more generally. Make sure that you cancel your units to end up with what you want and that each of these things inside the parentheses equals exactly 1. That was 6, so on to number 7. Number 7, you're given this graph here. A has a height of about 9, B 5, C 6, D 4, and E looks like 3.5. And it says the number of rooftops with solar panel installations in 5 cities is shown in the graph above. Okay, this is how many I have in city A, B, C, D, and E. If the total number of installations is 27,500, what is the appropriate label for the vertical axis of the graph? Well, note that if you add up these heights, A plus B plus C plus D plus E, you're going to get exactly 27.5. If you didn't want to spend the time to add them up really carefully, maybe you say approximately 27 or something like that. You get about 10 here, another 10 here, which gives you 20, and then another 7 or so here, which gives you about 27. Okay, so these add up to 27.5, but it told me it's supposed to be 27,000 and a half, 27,500. So what's the appropriate label? Oh, these must be in thousands. These are the number of installations I have in thousands. 27.5 thousands is 27,500. Number 8, for what value of n is the absolute value of n minus 1 plus 1 equal to 0? I'm going to start by setting it up as an equation like this. When you have equations that have absolute values in them, it is often useful to isolate the absolute value. So what I'm going to do is subtract 1 from both sides of the equation so that I have the absolute value by itself. Depending on the problem, depending on what I was doing with absolute values, at this point there's a bunch of different steps I would take. However, in this specific problem, all I have to do is recognize that what the absolute value of something does is it gets rid of the negative. It tells you the distance that number is from 0. So I'm taking the absolute value of something here. I don't know what the hell this something is, but when I take this absolute value, I get as my answer -1. That doesn't make sense. Right? There's nothing that the absolute value of it is equal to -1. The absolute value of anything is positive. The least it can be is 0. There's no such value of n. There's nothing that will solve this equation. My answer here is there's no such value. I suppose you could prove that to yourself. You could try taking a 0 and plugging that in for n. 0 minus 1 is -1. The absolute value of -1 is +1. 1 plus 1 does not equal 0. You could do that for the rest of these answers, and you'd see that none of them work. Or you could solve it this way and realize immediately that there's no such value. Number 9. Which of the following expresses... Oh, here we go. I got some information up here. A equals 1052 plus 1.08t. You see lots of these type of equations on SAT tests. They're what are called linear equations. So when you have a number all by itself plus another number times the variable. Nothing's being squared, nothing's being divided. This is what's called a linear equation. The speed of sound waves in air depends on the air temperature. The formula above shows the relationship between A, the speed of the sound wave. That's kind of annoying that A is the speed of the sound wave. I wish they'd call that S. In feet per second, and T, the temperature in degrees. Okay, at least T is temperature. That makes some sense. Which of the following expresses the air temperature in terms of the speed of the sound of wave? All this is asking you to do, aka solve for T. Take this equation right here, A equals 1052 plus 1.08t. And don't let the big numbers throw you off. Just solve this thing for T. Subtract 1052 from both sides of the equation, and you'll get something that looks like that. And then if you divide both sides of the equation by 1.08, you'll get A minus 1052 divided by 1.08 is equal to T. And since what you were asked to do was solve for T, you can just come look up here and figure out which of these is equivalent to what you just wrote. Looks like this one is, right? A minus 1052 divided by 1.08. This one's not because this is a plus. This one's not because my order of subtraction is wrong. And this one's not because it's all sorts of messed up. It's upside down and I got a plus here. Answer would be A. Number 10. At which of the following air temperatures will the speed of sound be closest to 1,000 feet per second? Okay, so a few options in terms of what you can do here. I have this formula above, which maybe I'll copy it so I don't have to keep rewriting it. A equals 1052 plus 1.08t. And remember, this tells you the speed for a given temperature. So what I could do is I could plug in all these different temperatures and figure out which one of those values will make A as close as possible to 1,000. Be one way you could solve this problem. Another way you could solve this problem is you could set your speed, the A, equal to 1,000. and solve this equation. So you can subtract 52 from, or 1052 from both sides of the equation, and then you divide by 1.08, and you'd get negative 52 divided by 1.08. And maybe you don't know what that is, but this is the calculator portion of this test, so it's easy enough to just pop that into a calculator. Negative 52 divided by 1.08, and what it spits out is negative 48 point something. Should have been more careful there. Negative 48.15, I guess. And you're like, I don't see that answer anywhere up here. Oh, right, which will be closest? This number is closest to this number, so therefore that's my answer. Another way, as I said, you could do this is you could just take those numbers and plug them all in. You could say I got 1052, and then to that I am adding 1.08 times, and then what I want is all of these different answers. So maybe I first guess negative 46 degrees, and I plug that in and I get this answer, and I'm like, that's pretty close. I wonder if that's closer than the next one. You could type the whole thing back again, but if you happen to have one of these TIs, you can hit second and then enter, and that pulls up the last line that you had, and then you can edit it and just change this to a 48. And note that this number is even closer to 1,000. And if you do that for the next one, you'll be like, oh, that number is not quite as close to 1,000 as this one was, and you do that for the next one, and you'll see that the closest is B here. As far as time, I don't know. I kind of think it's quicker to just go through it algebraically than to kind of guess and check plugging these all in. But I guess I'll leave that up to you. So there's the first 10. I'll make another video for the next 10.